Hey, you love them. Hello. Hey, Sian. Nice to see you. That is an awesome smiley face. That's Sian with 2 stars next to it. That's just amazing. Loving it. Do you know that I just had Harry send me a message on Google Hangout saying, Mr. Duncan, start the live. I want to do chem. He's a changed man. He's a changed man. Oh my goodness. Can you believe that? Hey, Harry. Good to see you, dude. Right. I get to see the register. Whoop, whoop. So who have I got? I've got Anch. Definitely think there's Anch. Sup, dude. Sup. I've got Minwee. Yeah. Who else have I got? I've got Ashley Potato. Oh, hey, Ashley. She's one of my year 10s. Minwee's in. Whoop, whoop. I've got Harry. I've got Sian. Smashing through the bit. Got Meryl. Yeah. There's Meryl. Yo, Meryl. I'm like the coolest person I know. I've got Mavella. Oh, it's MJ. Sorry. Hey, MJ. Sorry. I really struggle with all these people with their weird code names. Like, yeah. I'm just on my personal. Oh, okay. I've got Mavella. There's Mavella. Boom. She's in. Yeah, we're doing well. Like year 11s, did you notice that I posted a worksheet on the classroom? I am so sorry. It was so late. I thought I'd already posted it like 2 days ago, but I hadn't. But I'm just going to go through it today. And what you can do is you can just either pause the video, have a go, and then listen to the explanation. Or if you're struggling with that particular question, you can just follow me through it. Yeah, and I'm going to organize this to try and encourage that good routine and that good practice of how to answer these questions. Do I have anyone else? I'm still missing loads of people. There's Emmeline. Whoop, whoop, whoop. Yeah, there she is. I'm assuming maybe you guys can help me out here. Is this because you guys are slightly late from a previous lesson? Is that what's doing it? I'm just curious. Got Michael. You're Michael. Do you know what? Sometimes I genuinely forget that I'm live on YouTube here, and if this did ever go viral, I'd never work again. It would just be so embarrassing. Yeah. Let's not talk about that. Do I have anyone else? No, unless you click the E. Doesn't send notification. Ooh, did you drink a lot of coffee? And you know, I run on coffee. I'm just a caffeine machine. That's all I do. I wake up in the morning, 14 cups, boom. Yeah, get on the coffee. Did coffee drink Mr. Duncan? That is possible, Emily. It's possible that it's that way around. I think I am just like a living coffee drinker. Yeah. Anyway, I'm still missing loads of people. There's a Liz. Hi, Liz. Hello. Liz is in. Boom, she's in. I'm missing loads of people. Where is everybody? Come on, guys. Where's all my 11s? It's so upsetting. I mean, this is like the best lesson of the day, right? I mean, you're with me. And people are like, it's so upsetting. It's so upsetting. We all are dead. Come on, MJ. Better English. I say that I couldn't spell presents today, which isn't that awful? Not presents like Christmas presents, like presents like so and so presents. Couldn't spell it. Totally lost it. Isha, Julian, Catherine, Aisha, they're in. I like it. My screen has now started to shake. Oh no. Not that it matters. I can cope. I've got Isha. I've got Julian. I've got Catherine. Who else? I'm still missing a good load of people. Yeah, let's have a look. Got Julian, Isha. Yeah. That's a new low. I know. I just, do you know what? If you watch him laughing at 2 times the speed, it sounds crazy. How about that? That'll sound. Do you want me to do the coffee trick? Oh my god. You guys can record me doing the coffee trick and then you guys can speed it up. I can say coffee at lightning speed. Look at that. And then you can speed that up, but it'll be like insane coffee. See, look at that. There we go. It's amazing. I have skills. Hibber's in. Oh, Hibber's just arrived. No, I've already marked her in. Oh. I'm still missing people. Where is everybody? Okay, guys, I'm cracking on. Okay, so what I'll do is I'll just straight away share my screen. Let's get the screen going. Share screen. Share, then share that one. There we go. And then I'm also going to hide that bit, and then I'm going to disable my camera. It's probably not going to make much of a difference, to be fair, now that the screen's already shaking, but, you know, give it a go. There we go. Disable this. Can you... I reckon you could get the world record for saying the amount of coffee in 1 minute. I know, I totally could. Absolutely. Yeah. Absolutely. Right. Okay, guys. Right. So, GCSE Revision 6. So this worksheet, I picked it because it was just such a lovely worksheet to go over in terms of bonding. Yeah, I know that lots of people always struggle with bonding. It's one of the hardest. I'm sorry I'm late. There's Ira turning up. Let's do the register. I've got Ira in now. There she is. Nice one. Good to see you. Next. Right, go back to that. So, okay. So yeah, the worksheet was so nice because it covered such a great range of the bonding questions. And so I've set this, and as I said, what you can do today is you can pick and choose which of the questions you want to have a go at. I will then make some extension notes on these, just because it's always really nice to do this with you guys. I know that the majority of you, or at least, you know, a good few of you, are going to be going on to A-level chemistry. So I'll do the best to try and add those little extension bits on to make the understanding a bit easier. And often that understanding comes from the A-level specification rather than the GCSE, but we'll crack on. Okay, so the first question just simply said, write the following ionic formulae. So, and it's actually a lovely range of questions. So it actually started off with a really high level of an 8. If I were going to level these, LV, level. We've got a level 8 for A, and then ammonium bromide, again, a level 8, another love 8. And then iron 3 oxide, lower level, iron 3 oxide. But do you know what? That one is a really interesting one because it's a lower level question because it's not a complex ion. However, you need to know this one because this is rust. And you cannot forget, the most common mistake at GCSE, folks, is to forget that 3. You've got to have it because there's actually iron 3 and iron 2. And iron 3 is rust. Iron 2 is called a magnetite rather than a hematite. It's nice to say some ore names. And then we've got aluminium nitrate again, which jumps back up to a level 8 again. You'll notice it's very difficult to get to a level 9 with ionic formulae. It's really purely because there's only so far that you can go with things. There is one that does exist. And I'll quickly do that one over here if you wish as the extension question. So question E, this is your level 9, your love 9, and this is ammonium sulfate. Now, of course, I'm really hoping that you guys are going to understand why that is the level 9. The reason being is that this has got a simple ion and a complex. This has a complex and a simple. This one is simple, and then number 8 is simple complex. Well, this one's a 9 because it's complex. Yeah, you can't build either of these, folks. You've just got to know them, and that's hard. That you've just got to know it, and the chances of being able to do that just by guessing are essentially 0. So let's walk through the answers. Pause it if you want to have a go. And then you can go through the answers. So sodium sulfate is going to be Na+ and SO4 2- for the sulfate. Cross and down, folks. So what I'm doing is, I'm doing it in small. I'm going to zoom in on that one. Cross them down with the charge. The actual positive and negative vanishes, yeah, but I now get 2 sodiums. So I've got Na2SO4. So there's my final answer. Tick it if you got it right, folks. I'd love to get, and I don't know, but I remembered the complex signs. Okay, cool. You remember the names or the formulae? Anyway, so next, question B, iron 3 oxide. So this one is iron 3 plus. The Roman numeral is telling us the charge. Now, just a reminder, this is the extension notes. So Roman numbers, yeah, Roman numerals. Roman numerals are used in chemistry to give charges, charge values. Yeah, and obviously charge values for the transition metals, for the TMs. And you need to know up to 7, folks. 1, 2, 3, IV is 4, 5 is V, V1 is 6, and V with 2 is 7. That's all you need to know. I watched the first 4 minutes on 2 times speed. So that's what you guys need. So that's going to be +1, +2, +3, +4, +5, +6, and +7. So you need to know that because people often say, why don't I need to know 8? Because to come across an oxidation state or a charge, which is the same word, by the way, the charge value is at A level called an oxidation state. To come across a +8, very, 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 very rare. That's super uncommon. It does actually exist, but you'll never come across at a GCSE or A level for that matter. So let's now go for iron 3 oxide. So we've got Fe and then O. We know that oxide is always 2-. Cross and down. I'm going to need Fe2O3. Nice and easy. Next, onto ammonium bromide. So another complex here that you've just got to spit out. Ammonium is NH4+. Remember the difference between that and ammonia, please. Please remember that ammonia, one of the most important chemicals in the history of mankind, yeah, in fact, possibly the most important. It's given birth to 6.7 billion people, yeah. And then ammonium, be careful. Ammonium is the complex ion, NH4+. So do watch out for that, yeah. Just to say that ammonia is used to make fertilizer. Yeah, that's its main use. Comes up a lot. Ammonium bromide, we've got bromide from the periodic table as 1-. Cross them down. It's just a 1 and 1. So we've got ammonium bromide. That's it. Lower, that's 7, 8 really, but you know what? You'd probably say 8 because of the complex sign. Aluminium nitrate, Al+3 from the periodic table. Nitrate, you've got to know, NO3-. Cross and down. And I need 1 aluminium and 3 nitrates. This one's a tricky one. Aluminium brackets. This is trickier. Yeah, that one is trickier because we now needed a bracket. So that one really would be level 8, level 9. Yeah, because we've now got a bracket appearing. Right, and for those people who wanted the extension for a true level 9, a grade C A level, we've got NH4+ and SO4 2-. Cross and down. I'm now going to have brackets NH4, close bracket 2SO4. That's hard. Students often ask me, why does the ammonium ion come first? Because we know whenever we name or give a formula, yeah, name or formula / formulae, yeah, the positive ion always goes first in any name or formula. Hence sodium chloride, hence iron 3 oxide. The metal always goes first. It's just a naming rule. Right, next. Oh, right, a balanced equation for the following. I like it, nice and easy. So sodium oxide is being formed. So this is, by the way, this is the oxidation of sodium. And by the way, they can actually ask you a little bit about this. If you're going to, they could ask you what that would look like. You're taking a metal and you're burning it in oxygen. Now, if you do that, number one, sodium, of course, is going to be rather special because we're going to get a yellow, a bright a bright yellow flame. By the way, very, very bright. Yeah, it's going to burn with a bright yellow flame. That's what that's going to look like. I kind of feel like my screen now, by the way, has gone full meltdown, which is a nightmare. There's the metal, and it'll be extremely bright, like magnesium bright. Yeah, but it'll have this yellow color because it's the sodium flame test, which is quite nice. Next, right. So now we need to write a balanced equation for the following. By the way, you'll never the chances of you they can ask you to write a word, but they're super rare. So they just want you to balance it. So Na plus O2 goes to Na2O. Balance it. 1 sodium, 2 sodiums, do that. 2 oxygens, 1 oxygen, do that. But now we've got 4 sodiums, so we need to go back and change the sodiums. That's why they've done it, just to check that. The most common mistake is students will forget to go back to fix the sodium. That there is the common GCSE error. Yeah, they'll get 2 the oxygens and then the 2 there, which then doesn't add up for the sodium. Very common. Next, you're now translating much higher, by the way. Just to tell you, by the way, that's a level 5. That's a love 5. It's a love 5, that. Next, this is much higher. This is love 7/8. Because the reason being is, number one, you've got complex ions in here. You've got to remember your acids. And there's a whole load of little tricks. People will forget to balance. All kinds of problems here. Yeah, so we've got magnesium metal, Mg. Let's include a state symbol just for fun. Plus nitric acid. You've got to know this one, folks. That's HNO3. And it's aqueous. All acids are aqueous. And I'm forming magnesium nitrate. All nitrates are soluble. Complex ion. Magnesium will form a +2. Nitrate is NO3 1-. Crossing down. Yeah, I'm gonna need 2 nitrates. There we go. Hard this. And then hydrogen, of course, is diatomic. Any element ending in gene or N will be in a pair. Now everyone's going to forget to balance. So easily done, and you're finished. Yeah, all nitrates are soluble, and of course hydrogen gas is a gas. When they give you this in an exam, they will usually follow this up with, how do you test for hydrogen? Yeah, so you guys can pause the video and give me that. 2-mark question at GCSE. Yeah. You would light gas with lit splint. Light gas with lit splint. Yeah, and you will hear a squeaky pop. Squeaky pop sound. I'll zoom in. Squeaky pop sound heard. I'll just put the squeaky pop sound. I'll get you mark. So they usually tend to do that when they have that. Right. So what a lovely bit of practice, guys. When I saw the worksheet, I was like, winner! That's lovely, that. Because it's just such a lovely start to a bit of revision. We're doing some ionic formulae. We're doing some balancing equations. We're doing words to symbol. That's a great bit of revision right there. Right, and then on to a bit of atomic structure. We did some of this the other day, which is really nice. So again, reinforcing good practice. So first thing is, let's just, they've given us a full string of data for fluoride, which is quite nice. Now I'd expect to do the same thing for aluminium ion. So first thing is, it's an ion. Pause it, by the way, guys, fill it in. Mr. Duncan, is hematite rust? Cyan, technically, no, it's not. Just to explain to you why, that's really tricky. Hematite is a rock containing iron 3 oxide. This is hematite. And it's actually a rather pretty rock. I'll show you a picture of it. Show you a picture of what hematite looks like. Do I have anybody new to the lesson, by the way? I'm still missing people. Let's have a look at what hematite looks like. It's really pretty. I've always wanted some. Never really come across it. You're going to say it looks rusty. Yeah, there's a really beautiful piece of hematite. Isn't that lovely? Look at that. It's really cool. So what you realize is it actually has a very metallic look to it. This is not, isn't that magnetite? Wait, So what's Fe2O3? That's hematite. Sorry, have I made a mistake earlier on? Hematite is Fe2O3. Magnetite, sorry if I made a mistake. The other one is magnetite, which is FeO. This is magnetite. Oh, whoops. Magnetite. That's magnetite. I bet you can guess why it's called magnetite. It's because it's magnetic. Which is really, really weird, by the way, for a compound to be magnetic, but it is. So these are the two rocks. And can I just say, by the way, rusting is different. Rusting is super special. This is why we teach rusting completely on its own. Yeah, it gets its very own name. All other metals, only one metal rusts, and that's iron. Yeah, steel also rusts, but steel is just an alloy of iron. So only iron rusts. All other metals corrode. Yeah, all other metals, all others. No other metal rusts. Yeah, all other metals corrode, whereas iron rusts. And what do you need for rusting? We need iron, we need water, and we need oxygen. And that's the key thing, and that's going to give you rust. And just to tell you what true rust is this dot XH2O. It's actually a hydrated iron oxide. You're going to say, what's the value of X? It varies depending on the speed at which the rusting is being formed, and but it's a hydrated. That's a hydrated salt. Yeah, the dot means bound to. I'm going to put the X in as a little bit better. There we go, XH2O. So, but hematite has no water in it. It's just pure iron trioxide. That's why if you look at the image, Sian, it's such a lovely question. You can see rust on the outside. Look at all the lovely rust here, which is going orange. But there's no orange here and here. This bit here is hematite. And then the rust is happening on the surface because the water from the atmosphere is turning that hematite into a hydrated salt. Does that all make sense? Holy moly. So it is basically hematite hydrated. Yes, it is. That was a really long explanation. I apologize. Anyway, back to this. So let's do aluminium ion. So we've got, it is an ion because it's charged. It's not an atom. Atomic number 13. That's the bottom number. We know the atomic number of aluminium is there. Yeah, 13. Atomic number, mass number at the top. Oh look, mass number 27. Number of protons is the same as the atomic number. That is quite literally what the atomic number means. Number of neutrons. Yeah, we now need to incorporate these two. The number of neutrons is the mass number, which is the protons and the neutrons minus just the protons. So we're going to get 14. Number of electrons is the same as the protons. That's 13. Its electronic configuration. No! And I've just lost the mark. It was an ion. Oh, it's a trap. Oh, it's a trap. So you can't get rust from magnetite. You can get magnetite, grind it up into dust, and then put some water on it, and it will turn into rust. It's lost 3 electrons, folks. It's lost 3 electrons. It's a trap. It's a trap. Yeah, it's lost 3 electrons. So it should have 13 because of the 13 protons, but it's actually only got 10. So that means it's 2,8. The same electronic configuration as a fluoride ion. Guys, these two now here, this is now an A-level extension. These two are now, that is the worst. That was terrible too. I'm usually really good at these. There we go. These two are now called isoelectronic. Isn't that cool? Iso means the same. We get that from isotopes and isomers. Isotope is same identity. Isomers means same parts. Iso means same. And this is isoelectronic. They have the same electronic configuration. Isn't that cool? Yeah, so that's an A-level extension there. Next, an atom with 19 protons. Let's look it up on the table. Where's my table? I need the periodic table. Yeah, it's the periodic table, son. Brain cells. Okay, Emmeline, I think you're in the wrong class, Emmeline. Brain cells is biology. Yeah, you're in the wrong class. 19 protons is potassium. There we go, top number. Easy to get it confused. Everyone's going to go to the mass number, aren't they? Oh, I'm going to go fluorine. It's wrong. Check it. Check me. So we've got, this is potassium, and its bottom number is now going to be 19. Its number of neutrons is 20. So its top number is going to be 39. Right? It is an atom. Its atomic number is 19, the same as the protons. The mass number is 39. The number of electrons, it's an atom. The electrons balance the protons. 19 electrons, 19 protons. Configuration 2,8,8,1. Let's just check that on my beautiful, gorgeous periodic table. Let's just take a quick screenshot of that bad boy. I just want to quickly show you. Can you answer me? What? I said I did. I don't think so. Mr. Duncan, can you get rust from magnetite? I did answer you. I said if you grind. Oh, hang on. Oh, from magnetite. Oh, that's actually a really good question, Cian. Sorry. All right. I'm sorry. So magnetite. Magnetite is actually very stable when it's in a large rock. If I actually took magnetite, turned it into a powder, and I heated it, I would have to add heat. Yeah, if I added heat, it would oxidize to iron 3 oxide. Iron 3 oxide is more common than iron 2 oxide because it's more stable. So, yes, you can make hematite from magnetite. You take magnetite, you powderize it and heat it, and it will oxidize to iron 3. Yeah, can. Right, so just to show you the configuration, 2 people in that row, 8 people in that row, 8 people in this row, and 1 there. Yeah? 2, 8, 8, 1. It's all about reading the table. Now, I know that some of you are going to go, I don't want to read the table. I want to do it my way. I've learned 2882, and therefore I don't need to read the table. I've no idea what accent I'm doing. I'm sorry. So do Yorkshire. Hello. Oh no. Okay. Done Yorkshire. So reason why I'm not just getting you guys like I'm not doing it just to be like annoying. Yeah. Not trying that. What I'm trying to do is to get you guys to learn a methodology because you're going to need this for A level. When you get to A level, you've got to read table properly, and you got to use the same method. You got to go from left to right, cross periods. And you got to count people in row. That's the reason why. Yeah. Okay. Next. So we got 16 protons. Who's that? I think it's sulfur. Check my table. Sulfur. 16 protons. There he is. Hello, sulfur. So I got sulfur. Yeah, sulfur there. 16 protons, which means I've got 16 at bottom. Then look. Oh, number of electrons. Oh, he's got 2 more electrons than he does protons. He's an ion. He's an ion. A 2 minus sign. He's gained 2 more electrons. Yeah, his mass number is going to be 16 plus 18. It's going to be 34. 34. Its atomic number, of course, is going to be 16, same as its protons. Its mass number is going to be 34. And its configuration, I've got 18 electrons. 2,8. 8. There we go. -2 charge. Yeah, spot on. You can do -2 or 2 minus, makes no difference. Doesn't matter. You choose whichever way you want to do. I tend to vary between them. Whatever. Yeah, do either. Can. Right, so table all finished. Do you know what? I've got to figure out a way of you guys being able to give me like proper good feedback on how you found that. So, okay, guys. What's this going to be out of in an exam? I know that they'd never do this in an exam, although they could. It's a really good exercise. This is out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Would anybody like to tell me how many marks out of 17 they got on that? It's just, I need to figure out a method, and I might actually create like a Google sheet that ties in with the lesson. So that what we could do is, as I'm going through the webinar, you guys could be adding in like little numbers to the questions. I could probably do that. Some kind of spreadsheet. I reckon I could create one that I could use. One for each column. Sure. Yeah, that's actually a better thing to do, really, I think, isn't it? So 1, 2, 3, 4, 5, 6, 7, 8. Out of 8. Yeah, you could do one for each column or one for each one, and I don't really mind. Do one for each column. It'd be really interesting to see how you guys get on. I mean, as I said, I'm working on that. I'm thinking about it. As I said, I might create a Google sheet with your names running across the top, and then I can have question numbers, and then you guys can fill in your data. That might be a quite good way of me being able to track your progress. Okay. Next. Okay, so this one, of course, it's all bonding. Oh, I love this, guys. This is why I teach chemistry, because you guys are now at the stage where you can look at any compound and you guys can decide exactly what type of bonding it's going to be, and therefore you can actually predict what kind of properties they're going to have. Yeah. So let's have a look at this. So let's start off with aluminium oxide. Yeah, we're going to start here. Type of bonding. Giant covalent? No. There are only so many of those. They're rarities. Ionic? Yes. We've got a metal, non-metal. This is going to be ionic. Potassium? Giant covalent? No. Ionic? No, no. Non-metallic? Yes, because it's just a metal. Sulfur dioxide? Giant covalent? No. Not in these 6 ones I need to know. Ionic? No, that's metal, non-metal. This is all non-metals. Metallic? No, there's no metal at all. Next, molecular? Yes, this is simple covalent. Yeah, molecular and simple covalent, same thing. So saying it's a. I'd love, by the way, that's a great example of how I haven't managed probably to put that word in your heads enough in my lessons, but the worksheet's going to be really handy at being able to do that. Carbon, graphite, giant covalent, yes. Buckminster fullerenes, you guys need to know these guys. Yeah, they are not giants, they're not ionic, they're not metallic, they are molecular. Next, helium, monatomic. It's an element with 1 atom. Next, calcium bromide, metal, non-metal, ionic. Glucose, all non-metals, molecular. I like it. Once again, guys, if you want to give me some feedback on those, you're more than welcome to do so. You can tell me out of the 8, 1, 2, 3, 4, 5, 6, 7, 8. You can tell me how many out of 8 you've got. Quite like that. As I said, it's just really for me to just have you guys communicating back with me. Oxygen, right, guys, we're going into Susan Boyle sings Nelly the Elephant. I'm not going to say the other one. So we've got oxygen is a molecular substance, right? We now change that word molecular to simple covalent, or at A level, just covalent. It means the same thing. Right, and it says substances containing O2 molecules. Explain why oxygen has a very low boiling point. 8 out of 8. Sian, Emmeline, well done. Great job. Really proud. Thank you. You're doing great. Right. We are now running Susan Boyle sings Nelly the Elephant. So what does each of these represent? So the first S, of course, is structure. Then the B is bonds. Next is their strength. Next is how many are there, the number of bonds, and then the energy needed to break them. So we're just running our normal process. Thanks, Mel. Great job. Keep it up. So we've now got structure, bond, strength, number, energy. Good old Susan Boyle. So let's now run it. What's the structure of oxygen? So we've got oxygen. I'm going to do this as if I'm in a GCSE exam. Oxygen is a simple covalent structure. Next, the bonds. Right, now this is the important bit. Yeah, because in every simple covalent, we always know what bonds we're talking about. There are weak intermolecular forces between the molecules. I, of course, always shortcut between the molecules. I, of course, always shorten that to WIMPs, is what I always shorten it to. You're not allowed. Tom! Oh, Tom's here. Oh, did Tom not turn up? Oh, I'm really sad. Tom didn't show up. So my weak intermolecular forces, my WIMPs between the molecules. Next, how strong are they? These forces are very weak. I'm being messaged. I think it's Ange. Good job, Ange. Well done for remembering the complex science. It's going to hold you in great stead when you're doing GCSE. Really proud of you, dude. Keep it up. Really, really proud. These forces are very weak. Next, there are very few of these forces. There are very few of these forces. Therefore, not a lot of energy, not much of energy needed to break. These forces. So, and that's how I would do that in a real exam. And I would have SBSNE running down the thing, and then I put you just cross it out. Guys, in an exam, you just go bullet point, bullet point, bullet point, bullet point, bullet point, bullet point. Yeah, you just run like that. But as I said, you get this. This is how you should always answer these questions on bonding. Next, right, much harder question, because this one is now an essay. This is an epic, because we've got all the stories here, folks. Wow, it was not me. Who was it? It was you. Oh no, maybe it wasn't. I do have somebody else messaging me as well. Lol. Okay, diamond and graphite are both forms of carbon. Oh no. They both have high melting points, but only graphite conducts electricity. Explain these properties by discussing the structure and bonding in each substance. Right. So we need to go, right, diamond. In an exam, how would I do this? I would literally break it up. I'd do that, diamond, ... High melting point, high MPT, due to, right, and now I'm going to run all my bullet points from Susan Boyle. Structure, due to it being, oh, do you know what? Suddenly realized they both have, explain these properties by discussing them in each, okay. Yeah, I'm just going to do them all. High melting point due to it being a giant covalent structure held together by covalent bonds. There's my bonds. These bonds are very strong. Millions of bonds to break. Bonds to break. Lots of energy needed. That's all I'm going to do. Lots of energy needed. We're done. Oh, I've just run energy. Nice. Okay. Lots of energy needed. Full stop. Diamond does not conduct. Diamond doesn't conduct electricity. Because it has no free delocalized. It has no free delocalized electrons. You're done? That's it. There's diamond. Tick, 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 and millions. Can we say lattice? Yes, I'm sorry. I should have said lattice too. Giant covalent lattice. I'm sorry. I might lose a mark. Oh, simple covalent structure. Yeah, that one's not. But that one is a giant covalent lattice. I'm so sorry, Sian. Thank you for catching it. I do appreciate. My bad. Next, graphite. Graphite is a giant covalent lattice. Held together by, this is graphite special, by covalent bonds in layers. in layers and weak intermolecular forces. I'm sorry, I'm shortcutting it because I'm going to run out of space. And I know you're going to say, but what happens if you're in an exam? All right, fine. Comes in layers and weak intermolecular forces between the layers. Millions of all bonds must be covalent bonds really strong. Covalent bonds really strong. Very strong. All, this is graphite only. All bonds must be broken. All bonds must be broken. All bonds must be broken. Lots of energy needed. Lots of energy needed. Graphite conducts. Graphite conducts to each carbon making 3 covalent bonds. 3 covalent bonds. 4th unpaired electron. Unpaired electron becomes delocalized and can flow between the layers. Wow, look at that. That be crazy. Holy moly. I apologize, folks. I'm going to leave it there just a minute. You can always pause this. Look at all the marks. Giant covalent lattice held together by covalent bonds. These bonds are very strong. There are millions of them. Therefore, loads of energy needed. Diamond doesn't conduct as it has no free delocalized electrons to carry the charge through the structure. Graphite is a giant covalent lattice held together by covalent bonds and weak intermolecular forces. The covalent bonds are really strong. There are millions of them. Lots of energy needed. All bonds must be broken. Graphite conducts electricity. Electricity due to it. Carbon making 3 covalent bonds. 4th unpaired electron becomes delocalized and will flow between the layers. Oh, holy moly. That there, if you can do that, year 11, you can do anything chemistry throws at you. Yeah, that's awesome. They're just stories, and the stories you've got to know. They're going to ask it. They're going to be there. Keep practicing them, please, please, please. Next. Okay, carbon dioxide and silicon dioxide are both oxides of group 4 elements. No boiling point, while silicon dioxide has a very high melting point. Explain the difference by discussing the structure and bonding in each. Okay, so we're just running Susan Boyle on these guys. CO2. Structure, bonds, strength, number, energy. SiO2. Structure, bonds, strength, number, energy. That's all I'm going to do. That's it. I'm just going to go all of them. Right. So this is a simple covalent structure. Simple covalent structure, CO2. Weak WIMPs, weak intermolecular forces between the molecules. Between molecules, you'll notice I've dropped into short form. The strength of these is very weak. Strength of forces, very weak. Number of very few of these forces. Not much energy. Not much energy needed to break them. Done. Next, SiO2. Got to know this guy. He's a giant. It's sand, guys, or quartz. Structure. So SiO2 is a giant covalent lattice. Giant covalent lattice. Next, only covalent bonds. Only covalent bonds. Ooh, Only covalent bonds. Covalent bonds. Covalent bonds. Very strong. Very strong. Number millions. It's a giant. Millions of bonds to break. Millions of bonds to break. Energy very high. Energy very high. Lots of energy needed to break the bonds. It's just a story, folks, and you just run it. I think we're on our last question now, folks, which is amazing. Aluminium metal. Oh, by the way, I'm just going to take it there, and you can pause it and go over them if you want to. Check your answers. There you go. Aluminium metal is extracted from aluminium oxide by electrolysis. The aluminium oxide must be molten to conduct and melt at 2072 degrees Celsius. Explained by discussing structure and bonding why aluminium oxide must be molten to conduct and why it has a high melting point. Right. Al2O3. Susan Boyle sings Nelly the Elephant. I'm actually made the B too large. Susan Boyle sings Nelly the Elephant. Right. Structure. Aluminium oxide, Al2O3, is a giant ionic lattice. Giant ionic lattice. The bonds held together by the electrostatic attraction. The electrostatic attraction between oppositely charged ions. Now, in this case, I'm actually going to go to the A-level bit, held together by the electrostatic attraction between, I'm just going to name the ions. This is just the A-level bit, between Al3 plus and O2 minus. Yeah. Next, strength, because it tells me that they're opposite charges. Yeah. Strength, really strong. Strength of attraction, very strong. V strong. Next, number. It's giant. Millions of bonds to break. Millions of attractions to break. Energy, really high. Energy, lots of energy needed to break. I like it. ... needed to break. Next. So, explain why it only conducts when molten. Right. So, aluminium oxide, when solid, ions are unable to move to carry charge. When molten, ions become free to move to carry the charge through the structure. And we're done. Yay! That brings us to the end of our revision. Isn't that amazing? What an amazing set of stories. And they're all, I mean, it's just, I love the worksheet. It's absolutely on point. It has everything that I needed for revising for structure and bonding for GCSE Chem. Guys, so you can pause that if you need to, by the way. I'm going to go back to StreamYard. Going to turn my camera back on, if I can. Enable. Turn that back on, and then do start cam there, and then go to that one and go, hello! U11, thank you so much for coming along. I hope you found it useful. I'm going to post on the classroom another revision sheet, and I will go through it in our next webinar. It's so nice to see you all. Please, I worry about you. I miss seeing you guys. Take care of yourselves. Be safe. And I'm really looking forward to seeing you guys next lesson. Take care, guys. It's nice to see you.